Hello, algebra students. How's everything going, guys? I hope you guys have had a good week and a half since I've seen you. And I know it's been a while, but we're just going to kind of jump in right back into the mix today. Continuing where we left off with CPM here, 9.3.1. Today we're going to focus on graphing two variable inequalities. Okay, so if you recall the last time we left off, we graphed inequalities in regards to one variable, where it was just x, and we graphed using the x-axis or a number line. But today, we're going to be going with a coordinate plane. We're going to take a look at what that looks like. It's actually pretty straightforward. And, some of you guys might have had experience with this before, but yeah, let's just jump right in here. So 9.3.1, what if the inequality has two variables? In section 9.2, you learn how to use an inequality with one variable to help solve a word problem. You also discovered that a one variable inequality can have 0, 1, or more solutions, and that these solutions can be represented on a number line. But what if an inequality has two variables? What is a solution to a two variable inequality? How could these solutions be represented graphically? Okay, so let's look at the first one here, 9-65. So before we begin, just remember, hopefully you guys are trying to learn this as you're watching this video, or maybe you even tried to do the problems before watching this video. That way, you can't really simulate what it's like to be in a classroom with a group of students. So a lot of this, you're just gonna have to try and do it on your own, and then hopefully this video, you can watch it, rewatch it, rewind it, pause it, do what you need to do to help you better understand the concepts. But it's a lot more effective if you try to do it beforehand and realize where you're getting stuck and what you're unsure of. Okay, so let's move along. 9-65 gives you an equation, y equals negative 2x plus 3. Okay, and it says to compare your graph with a poster graph provided by your teacher. Well, obviously don't have a poster, but I do have a graph right here. Okay, this is the equation y equals negative 2x plus 3. 9-65 then says, part A says, is the point negative 1, 5 a solution to this equation? How can you tell by looking at the graph? How can you tell by using the equation? So the point negative 1, 5 is going to be right there, right there, negative 1, 5. And because it lies on the line, that point is actually on this equation of this line, it is a solution. Okay, so that's how we know graphically if it's a solution or not. Now it says, how can you tell by using the equation? Pretty simple. You just take the equation, y equals negative 2x plus 3. You're going to substitute the two values in there of x and y that's given to you, and we make sure that both sides will equal each other when we simplify. So for example, let me find some space here. If I have y equals negative 2x plus 3, I'm going to substitute for x and y. My x value is negative 1, my y value is 5. I'm just going to start solving this on both sides, on each side, to see if it's true. I'm just going to simplify each side, I should say. Negative 2 times a negative 1 is a positive 2, plus 3 is 5, and 5 does equal 5. That's how we know this is true. Okay. Next question, part B says, is the point negative 2, 2 comma negative 1 a solution? Well, let's look at 2 comma negative 1. Here is 2, down 1, right there. That is definitely going to be a solution, right? How about 0, 0? There is 0, 0, the origin, not a solution. Okay, and it says to justify it with the graph and the equation. I just justified it graphically. You guys will be able to do this on your own if you want to check your work algebraically using the equations. Go ahead and substitute 2 for x, negative 1 for y, and see if the left side equals the right side, and then you can do the same thing for 0, 0. Okay, 0, 0 is actually really quick and easy to check, right? Because if you plugged in a 0 equals, well, negative 2 times 0 is going to be 0, plus 3. So you don't even need to do that. You're asking yourself, does 0 equal 3? And obviously not. So that's obviously not going to be a solution. And part C says, what determines if a point lies on the line? What is the difference between the points on the line and the points not on the line? Well, the points not on the line is 0, 0. It is not a solution. Points that are on the line are 2, negative 1. It is a solution. 0, 3. It is a solution. If it's on the line, it's a solution. If it's not on the line, it's not a solution. Pretty straightforward. I know you guys know this. I know you're thinking this is a waste of time. Why are we doing this? But it is super duper important. Okay. All right. 9-66 says, we're now going to graph linear inequalities. So in the previous problem, we found that the points on the line are the only points that make the equation true. But what if you want to graph solutions for the inequality y is greater than or equal negative 2x plus 3? So it's pretty much the same equation, or the only thing that's different is the inequality is now greater than or equal to. Okay, so how would that graph differ from the graph of y equals negative 2x plus 3? Consider this question as you follow the steps below. You're going to give a list of points to test. Now, again, if this were a class, I'd give each group a bunch of different points, and I'd have you guys come up to my board here and place the points directly on this graph, and I'd ask you if they are solutions or not. Right? Again, this is not an equation. This is now an inequality. Y is greater than or equal to negative 2x plus 3. So I'll just give you some random ones here. In fact, I've got some right here. This is what it would look like, right? Let's see if this one is. I'm going to start working on this. Let's see if negative 2, 7 is. Negative 2, 7 looks like it's right there. I think that's going to work. Let's try 1, 1. Hey, another winner. How about 4, negative 1? 4, negative 1. Ooh, that's not on the line. But again, this question isn't asking if it's going to be on the line or not. It's going to be asking if these are solutions to the inequality of y is greater than or equal to negative 2x plus 3. And, you know, again, if this were class, I'd just give you a bunch of points. You would test them and see which one would make sense, which ones wouldn't make sense. And then you'd answer the next questions, right? So you notice we've got, I've just selected 5 points, right? I've got 2 points that are on the line, right? Then I've got 2 points that are to the left of this line. And then I've got that 1 point that's to the right of the line, okay? So again, you recall the inequality is y is greater than or equal to negative 2x plus 3. So here's the line of negative 2x plus 3. That's the line, right? Then if y is greater than that, we're going to see what that looks like right now, actually. Let's go back here. It says, are there any points on the graph that you suspect are solutions but don't have a sticker? Are there any stickers that you may think may be misplaced? If so, verify these points so that you can have a complete graph of the solution. Okay, what about the points that actually land on the line? Are they all solutions to the inequality? Why or why not? So, because this is y is greater than or equal to, okay, that means if it's on the line, it's still part of the solution, okay? The last question says, how many solutions are there? Well, we have to ask ourselves what's a solution and what's not a solution. So if you recall, one of the points I chose was 4, negative 1. I think that was one of them, okay? And I'm just going to substitute that value into our inequality here, okay? Let's see if this is true or not. So 4, negative 1 is that point right there. 4, negative 1. I'm going to substitute it back into my inequality. Y is greater than or equal to negative 2x plus 3. 4 is my x value, negative 1 is my y value. And I'm just going to start solving this to determine if this is true or not. Okay, I get negative 8 plus 3. That's going to be a negative 5. So I have negative 1 on the left, greater than or equal to negative 5. And we're going to ask ourselves, is this true or false? True or false? Right? Is negative 1 greater than or equal to negative 5? Well, there's only one way to find out. Let's put it on a number line. Here is the number line. Right? Here's negative 5. There is negative 1. Right? That's negative 4, 3, 2. And because negative 1 is to the right of negative 5, as we go to the right, things are getting greater. So negative 1 is certainly greater than a negative 5. So this is going to be true. If that's true, that means this point, let's go back to the graph here, that point is a good point. It's true. That means it's part of the solution. Okay? So if it's part of the solution, you have to ask yourself, okay, well, is this above my line? Is this point of 4 comma negative 1 above my line, or is it below my line? Okay, again, this is a very important question that you're asking, because this is true. This is a true point. It is a solution of this inequality. Here is my line again. Is it above or below? Well, above, you don't want to think in terms of left to right. You want to think above or below. This is actually technically above my line, right? Some of you guys think, well, it's to the right, but it's technically above my line. If it's above my line and it's true, meaning it's part of my solution, that means everything above my line should be shaded. And so everything that is above my line is part of my solution. Okay? Anything. I can have another point right there, another point right there, another point right there, another point right there. It's all part of my solution. Right there, right there, right there. In fact, how many solutions do I have? Answering this last question here down at the bottom, how many solutions are there? Well, there's an infinite amount, right? Everything that is greater than or equal to that line. So remember, if it's still on this line, it's still part of my solution because it's or equal to. If it's equal to, that means it's on the line, that means it's good. Okay? All right, let's move along. 9-67 says, what else can you learn about solutions of linear inequalities? Think about this as you answer the questions below with your team. Again, you won't have a team. So what if it's shaded like this right here? Okay, what if it's shaded like this problem? What inequality would correspond to this graph? Well, this now we're shading the bottom side, right? Find the line here, and it's shading the bottom side, below this line. So if it's below, ask yourself what inequality would make sense, right? It's going to be a less than, because you're below it. So part B says, how do you ask, what if I change the inequality to y is less than negative 2x plus 3? What would the graph look like? Well, right now would be a great time to pause if you haven't done this problem yet. What would this look like, right? Now, y is below, less than, so it's going to be below this line, right? It's going to be below the line, but should this line be the same thing? Should that line change at all? All right, so go ahead and pause it for a few seconds, maybe 30 seconds or so. What would that line look like if it's just less than? Remember, it's not less than or equal to, it's just less than. Okay, so hopefully you paused it, you thought about it for a little bit, and now we are going to talk about this problem. So because it's less than and it's not less than or equal to, what happens if you have a point on that line like that? Is that part of a solution now? Is that part of a solution? Is that part of a solution? Well, in fact, let me give you a better one. 0, 3. Let's try to solve this algebraically. 0, 3 means y is less than or equal to negative 2x plus 3. Here is 0. Y value is 3. Okay? Again, we're just solving this algebraically. 3 is less than negative 2 times 0 is 0 plus 3. So we have 3 is less than 3. Is this true or false? Is 3 less than 3? Absolutely not. This is false. 3 is equal to 3. So that means the point that we tested right there, that point is not a good solution, not a good point. It's not part of the solution because 3 is not less than 3. So that means if it's now on the line, it is no longer a solution because we said y is less than, emphasis on less than, negative 2x plus 3. So what type of line should this be? Well, if you recall, when we started doing the number line, when we started graphing, right, we had an open circle for less than, and it went to the left. Well, we're going to kind of think of the same process here, but instead of having a bunch of open circles, that would be kind of weird looking, right? So we don't want that. So instead, we're going to do a dashed line or a dotted line. Okay. Everything else is exactly the same. We still want to shade to the left, or excuse me, underneath like that. And that's how you would graph it. You would have a dotted line, and then you would shade it below because it's less. Less is below. Greater is higher, right? So very simple to remember. Hopefully you guys won't get confused. Okay, let's move on to our next problem here. And this is pretty much our last one for the day. If you guys haven't done these problems already, I highly advise you to pause the video and then graph these next 4 problems without a calculator. Just graph them on your own and practice with the shading. Ask yourselves what type of line should it be. Should it be a dashed line or a solid line? And that's it. So give yourself a couple minutes. I would pause the video right now and come back to it. Alright guys, so here are your answers for 9-68. If you look at problem A, it is y is greater than negative 1/3 x minus 1. So greater than, it's not greater than or equal to, so we do a dashed line if it's just greater than, right? Because it's greater, we shade above. Okay, greater than, we shade above, right? For problem B, it says y is less than or equal to 4x plus 2. Well, there is the line 4x plus 2, and less we shade below. This is where it could get confusing sometimes, as you always want to just ask yourselves, put your pencil on the line and just, line it up with that line, put your pencil on top of it, and if it's less, just move your pencil in a downward motion, and that's where you're going to shade. Okay, and then for part C, is y is less than 5/2 x plus 3. So again, less than, if you put your pencil on the, like that, just put your pencil right there, and if you move it downwards, you will notice that this part's going to be shaded. Okay, and then the last one's a little bit trickier, is 2x minus y is less than or equal to 5. You're going to have to do a little bit of work here, right? So if you have 2x minus y less than or equal to 5, you're going to have to put this in slope-intercept form. So negative y less than or equal to negative 2x plus 5. And if you recall, you would have to get rid of that negative in front of the y, negative 1, by dividing or multiplying by negative 1. Here I divided. And because we're dividing by a negative, that inequality now changes to greater than or equal to. Again, that's why you see the shading is slightly different. It's going to be a 2x minus 5. Okay, so if it's going to be greater than, we are shading in an upward motion. Okay, that pretty much wraps it up for this lesson, guys. Hopefully everything made sense. If you want to go back and do 9-69 in your learning log and answer the following questions to help you understand things better, I highly recommend that. It would just take you, no longer than 5 minutes, but be very, very helpful. Make sure you guys do the homework problems tomorrow. And again, if you have any questions, click on that Calendly link on my Haiku page and set up an appointment with me, and I will gladly do a video conference with you and answer any questions you may have. All right, guys, stay safe out there, and have a great day. Hopefully everything's are slowly getting back to normal for you guys, and hopefully I'll see you sooner than later. All right, take it easy. Bye.